So we're just going to do a little review session today. I'm going to do some of your practice problems. You will still get different values, so you should do it yourself also. So your test will be due October 1st at midnight. I did send the announcement, so you should have that information. And it has 25 questions. You get 90 minutes. We will not have a Zoom session this Thursday. It'll just give you a little more time to get ready or to actually do your test if you want to do it during that time slot. So, I thought we'd just look at the review. Anybody have questions? All right. You should make sure that you have a calculator, a handheld calculator, to use for your test because you really need it with some of these radicals. And you can't use one that's on the computer, or you can't use a cell phone while you're doing a test. Okay, so let's go ahead and go into my Open Math. And we'll just do some problems. So this one is just simplifying a radical. So 81y squared. Hopefully you would recognize 81 is a perfect square. And so this would be 9. Square root of y squared is just a y. You can divide by the index. 2 into 2 will go one time. So it goes out from under the radical, and it's done. Question 2 has a cube root, and it has a fraction underneath. You can always look to see if there's something in common in here. You could reduce first, but there is not. So we'll break it apart and make two radicals. Cube root of 64 and cube root of 125. These are both perfect cubes. Make sure you could find that on your calculator. So you would want to make sure you knew how to do cube root on your calculator. For this calculator, it does not have a specific cube root button, so I have to use the any root button. So I will do the 3, and I have to do second, and I'm going to use this any root, which is above the caret. That's why I had to do second. And then I will do 64, enter. And so that's my numerator is 4. And then you do the same with 125. So 3, that's for your index. Second, any root, 125, enter, and the answer is 5. So your total answer is 4/5. All right. The next one asks us to simplify this radical without using a calculator. And so that lets us know it's not going to be a perfect square. We simplified these in class by breaking to primes. And we're going to use a calculator here just to help us divide 98 divided by 2. But we're not going to do the square root on there. So 98 divided by 2, and I picked that because I couldn't think of anything that goes into 98. Sometimes something nice will pop in your head, but this one doesn't. It ends in an even digit, so that is why I started with a 2. And then it actually breaks down pretty fast. There is your perfect square, that 49. So 1/7 will go outside for the radical, and the 2 will stay inside. That is a simplified form of your radical. So I'll type this one. You should have already practiced one like this. All these are coming from the homework. So 7, and then your radical button. Don't use this one. It puts it as a index. So if you were doing a different root, you would pick that one. All right, so it should look like that. 12 is, question 4 is the same kind. You would break 12 down. So I will skip it since it's the same kind. Question 5 is the same kind but a different root. So we can try that. So it is a cube root of 160. So we want to break to primes. This one is not bad because it ends in a 0. That means there is a 10 in there. So 10 times 16. 10 is 2 times 5, 16. Anything that multiplies to give 16. And those 4s we can break on down. All right, so we want groups of 3 things to make a cube. So if I use this and these 2, that will make a cube. 1, 2 gets to go to the outside for the group. Everything else has to stay. So we have 5 times 4 is 20. And this will be this is a cube root. Make sure you keep the index. So 2 times the cube root of 20, we'll type that one in. So your 2 would go first, and then your root button with an index on it, with an N. All right, and it just has the cursor up there. It doesn't have a little shaded box for you. That's the 3, and then click down here to get underneath. So we broke it down the same as squares, just your index tells you how many copies to put in a group. So we had to do 3 copies in a group. So any root would be done the same way. All right, this one just has variables, and it's too bad that the computer used an I there. It generates the variables randomly. The I we've been using for square root of -1. That is not what it means here. It is just a random variable here. So C to the 20th and I to the 8th. And so this one is testing, do you know how to simplify this? Divide by the index into the exponent. So the index is 2. 2 into 20 goes 10 times. And it goes evenly, so we're going to take a C to the 10th to the outside, then divide 2 into 8. It goes 4 times, no remainder, so those go outside. There were no remainders when we divided, so these were perfect squares. Right, and we're just going to look on that one. All right, number 7 gives us 361 over 9. You could look to see, does anything common go into these? Well, the only thing that goes into 9 is 1, 9, and 3, and I don't believe that goes into 361. If it did, you would be done. Maybe we should check. I'm sure it doesn't. Okay, it doesn't. All right, so let's put the radical with the numerator and put the radical with the denominator. All right, denominator is easy. That is a perfect square. That is a 3. I don't think there's anything you can do with 361. If you tried going with primes, I mean, it doesn't fit any of the rules that we have. It does not end in an even digit. It doesn't end in a 0 or a 5. And there is also a little shortcut I'm not sure I've ever told you guys, but a divisibility. If you add all the digits, if that is divisible by 3, then the whole thing is. But this is 9 and 1 is 10. 10 is not divisible by 3, so neither is 361. So I am thinking that that is all we can do. And we'll just look. Mrs. H was wrong. I hope that question is not on your test. Okay, one of that form. If it is, you get that weird number there. You know, and I could have checked, but I thought I did check. Oh, I divided. I didn't check if it was a perfect square. So I could have checked, is this a perfect square? 361. It is a perfect square. Okay? It was just huge. So I really should have done that first. Okay, so Mrs. H is wrong. And this is 19 over 3. It was a perfect square. So don't fall into that trap. If you get one with something big like that, just make sure it's not a perfect square to begin with. All right. Question 8. This one is testing, do you know how to simplify these variables? They're all going to divide evenly. We'll do it just because it looks a little scary. All right, so cube root of negative 125, that should go in your calculator. It is a perfect cube. So I have to do 3 second, any root, negative is down here, 125, enter. And that is a negative 5. For your variables, you're going to divide by the index. 3 into 27 goes 9 times, and that's even with no remainder, so that goes outside. 3 into 12 goes 4 times, it's even with no remainder, so it goes outside. And 3 into 9 will go 3 times, even with no remainder, so they're all outside. Whoops. Right. Let's have a look at this next one. I remembered something like that being on your test. And I don't remember us doing it in a session. So, it's just a plug-in problem, right? So we have a formula which models the maximum safe speed, v in miles per hour, at which a car can travel on a curved road. A highway crew measures the radius of the curvature at the exit ramp as 370 feet. What is the maximum safe speed? So v is going to be the maximum safe speed. In here we have 2.5. R is the radius, and that is what you're plugging in. The radius of curvature at the exit ramp is 370 feet. So this is going to be 370, which will multiply times the 2.5, and we'll take the square root. They say for this problem, round down to the nearest whole number. And then they ask, well, why might you do that? If you want to make sure that something is safe, you want to be conservative. So you would round down. All right, so I would definitely throw this in the calculator. And if you're good with your parentheses, you can do it all in one shot, right? So we could do the square root first, second square root, right? And we have 2.5. It actually put a parentheses on there, so we can go ahead and do times 370 and close the parentheses. That will make it work inside first, and enter. So all you had to do was write that in your formula. It looks like a long word problem, but write it in your formula and then plug in. Then it's a calculator problem. So we have 30, and I'm just going to go 0.41 because they ask us to round down to the nearest whole number. So our nearest whole number is here. This is the whole number. So we're going to round this off. And so 30 should be our answer as the maximum safe speed. Good. Okay. So even if this was 0.75, we would still round down only because of their directions. All right, so question 10. So these are the rational exponents. Remember the fraction exponents? That's what's coming up in these next sections. So the 15th root of x to the 11th. They want you to change and write it in rational exponent form. I always remember that the index is the denominator. So I'm going to make a fraction. This is the 15. Whatever else I have goes in the numerator. If that would reduce, you should reduce. And that's how they want the answer left. 11 is a negative exponent. Remember, you have to shift a negative exponent. So we're going to shift this one first to the denominator. And they want us to evaluate it. So we have to see if we can do a little bit more. This is a cube root, and 125 is a perfect cube. Hopefully you'll remember that one. So we're going to switch to the radical form. I'm putting the 3 on. I'm holding the 4 for just a minute. If this piece is a perfect power, then put the 4 to the outside. And it is. You can test cube root of 125 is 5. So it is a perfect power. So I'm going to choose to put the 4 on the outside. All right, so cube root of 125, do that on your calculator. You get a 5, and then we have 5 to the 4th. So 5 to the 4th I will have to do on my calculator. I think it is 625, but I'm not sure. Yes, it is. So you get 1 over 625. But you do have to shift to the denominator first there. All right, next one is an easy one. This is a positive exponent. Just trying to look a little closer. 25 to the 1/2. This is square root of 25. And hopefully you would know that is a 5. So you'd be happy if you get one like that. Right, 13, you're going to have to do arithmetic with fractions, but use your calculator for that. So we have like bases as a fraction or like bases divided. the rule is to keep the base and subtract the exponents. 5, 6 minus 1, 6. Now, this one is not so horrible because they have a common denominator. And so the rule is keep the common denominator and combine the numerators. You would just need to reduce that fraction. It has a common factor of 2. So 2 will go into 4 2 times, and 2 into 6 will go 3 times. So x to the 2/3. They would want you to leave it that way, not switch to a radical. And it was easier because they gave us a common denominator. If it's not a common denominator, I would do the math in a calculator. And so you should make sure that you practice that. And the parentheses don't really matter that much. We could have just had a dot in there and it would be the same. They had both, right? So that was overkill. This is like bases. Multiply, the rule is keep the base and add. So we're going to add a half plus a fourth. All right, this is one that you should make sure that you know how to do on your calculator so you don't have to spend a lot of time doing fraction arithmetic here. Let's see, this calculator has a fraction button, and I don't have it in the multi-view mode. I have it in the mode like the other calculators. So for me to enter, I'm going to do 1 fraction button, 2 plus 1 fraction button, 4, enter. All right, so I get x to the 3/4. Much faster than doing it by hand, where you have to get the common denominator. If you have a graphing calculator, you don't have a fraction button, you could enter this as 1 divided by 2, but put the entire thing in a parentheses. So if I had that kind instead, and that's not required or even recommended for your class, but if you have it, I don't care if you use it. Right? If you were going to do the fraction math on here, you have no fraction button, so you would instead do 1 divided by 2, keep the whole fraction in parentheses, that way you have the whole answer. All right, plus fraction button for the second one, 1 divided by 4, enter. Now, it's going to give me a decimal, but I don't want a decimal. So I do math, and then I go back to fraction choice number 1. And then I get the 3/4. So the graphing calculator there takes you a little bit more time than the scientific calculator. All right. But that will work on any calculator. If you don't have a fraction button, the issue will be make sure that you know how to switch back from a decimal to a fraction on your calculator. So play with those on your calculator. All right. This next one is a trick, kind of, and I see lots of students miss that. Which is too bad. So maybe you guys who are here will not miss that. Okay, I want you to switch to radical form, and what you have to know is this exponent only goes to the x. It does not go to the 3. It only would if you were in parentheses. So this is 3, and it is a 10th root of x to the 7th. There you go. All right, 16. So I have 81 over 16 to the 1/4. So this is a 4th root. If this would reduce, you would. So we'll go ahead and do the radical. And I can't think of anything to reduce it with. So we'll go ahead, whoops, bad mistake, Mrs. H. Put your index on. So we'll go ahead and do the 4th root with the numerator and the 4th root with the denominator and see if that simplifies. It certainly will some. I know that denominator is a perfect 4th power, but if in doubt, check it. So we're going to do a 4th root, second, any root, 16. That is a 2, and I believe that 81 is also a perfect 4th power. So 4, second, any root, 81, enter. So 3/2. Good. All right. The next one, do it the same way. It's a 5th root. These are going to be perfect 5th powers. All right. This one, you want to simplify, and it just has a number on the outside of the radical. So 5 times the square root of 63. So break this down, and we could do 9 times 7. 9 is a perfect square. And so we're going to take a 3 to the outside. It will multiply by anything that's out there. So 5 times 3 will give us 15. The 7 is going to stay under the radical. So 15 times the square root of 7. 19 is the same kind. You break 50 down, take out what you can, multiplies by 5. Right. 20. So we have square root of 50 over 18. There are some common factors in these right now, and so you should go ahead and divide it before you break it apart and make 2 radicals. I know that there is a 2 in both of those, so I'm going to reduce it with a factor of 2. 2 into 50 goes 25 times, and 2 into 18 goes 9, which is very nice because it actually gives us perfect squares now. So we'll break it apart. The radical with the numerator, radical with the denominator, and square root of 25 is 5, square root of 9 is 3, and it's done. So if there's something common between this numerator and denominator in the fraction under the radical, reduce it first. All right, let's see, 21. This is a 5th root of b to the 4th over 1024. Right, number 1, they have nothing in common. So we would go ahead and break it. You can't simplify on the numerator. The 4 and the 5 have nothing in common. Also, 4 is smaller than 5, so you can't divide and make it smaller. So let's check out and see if 1024 is a perfect 5th power. So 5, second, any root, 1, 0, 2, 4, enter. It's 4. So your numerator stays the same. 5th root of b to the 4th over 4. And if you're going to enter this, you should do your fraction button first. And we're on the numerator, so we want any root. And we do the index, and then click underneath. We have B, you have to do the exponent, 4, and then you want to be down here, 4. Half the time entering it is the issue. All right, so 22. Let's see what we have going on here. These are radicals that are separated already into numerator and denominator. If it would help you with all the pieces, you might put them back together and simplify and then separate them again. 8 and 25 is not going to help you. So I would go ahead and clean up. This 25c to the 4th is a perfect power. Square root of 25 is 5. For your variable, you're going to divide by the index. 2 will go into 4 2 times. No remainder, so no radical left. For your 8, 8 gives us 4 times 2, and 4 is a perfect square. So we're going to be able to take a 2 outside for the radical. For the 8, on the c to the 8, divide by the index. 2 will go into 8 4 times. So c to the 4th goes outside, no remainder, so there's no c's left. Now, you did have a factor left from the 8 itself. So a 2. And when you start entering that, start with the fraction button. Oh, I didn't finish it. That would have marked you wrong if you left it like that. These are outside. I should have cleaned them up. Once they're outside the radical, just see if it will reduce. So you have 4 minus 2. So we will have just 2 c's on the top. And that would get us, so these subtract. Sorry about that. Okay. This next one gives us one where you're going to have one piece that is not going to divide evenly for the exponents. So we have 100, c to the 7th, g to the 4th. 100 is perfect square. This is a 25. The c to the 7th, we're going to get a remainder, so we're still going to get a radical back there. We'll divide. 2 into 7 goes 3 times. 3 times 2 is 6. 1 left over. So you're going to take 3 c's outside, 1 c left inside. And this was the c's. The g's divide evenly. 2 will go into 4 2 times. So you have 2 g's outside. You still have your radical just for the c, and there was 1 c left over. And Mrs. H messed up right here. Square root of 100 is 10. It is not 25. That would nail you for that. Square root of 100 is 10. So hopefully we're good now. Okay. All right, we'll do 24. I was looking to see 25 because it had more, but it is actually all going to divide evenly. So 24 will give us more variables to practice on. So you're going to divide by 5. And see what goes outside and what goes inside. All right, so 5 into 19 for the x's. we'll go 3 times 3 5s are 15, and you've got 4 left over. All right, so these go outside, and this is the x's. So x to the third is going outside. All right, your y's divide evenly. 5 into 10 goes 2 times, so they all go outside. And then 5 into 18 does not go evenly. 3 5s are 15, and you have 3 left over. So 3 go outside and 3 go inside. So this is z to the third. You put your radical back, and we had leftovers on the x's. We had 4, and we have leftovers on the z's. We have 3. So this whole thing should be your answer. Good. All right, I'm going to skip 25 because they are perfect powers. This one, because of where it is in these questions, I think that they are not thinking about you knowing how to rationalize a denominator yet. So something you could do is you could put these both under the same radical because you see a common factor there. And right now, neither are perfect powers. So you could put this all together, and you could divide 5 into 125, and that will go 25 times. Then you won't have a denominator. Your 25 is a perfect power. The square root of 25 is 5, so it goes outside. The x is left under the radical. That is the easiest way to work that problem. So you see something in common between the numerator and denominator. They're all under radicals. You can put it back together. So we'll do one more like that. So this one I think is going to be the same way. 108 x to the 5th over 3x to the 3rd. I'm pretty sure that 3 goes evenly into 108. So let's put it back into one radical. And we'll divide it. Whoops, wrong calculator. 108 divided by 3, 36. So I can divide that out. Gives me a 36. I'm still under a radical. The x's are going to subtract. 5 minus 3 leaves us 2. Right, and this is a perfect square, so this gives us a 6x. So that was the nicest way to work on that one. All right, now it's getting into addition and subtraction, and you have to make sure you have like radicals. Just looking to see if there's a nice problem here. These are all nasty, so we'll just work a nasty one. And it's because some of these are so big, that's why I said that. You have to have the same radicand for these to go together. When I finish this little part, I'm going to go to the end and work some of those with the eyes in case I don't get that far. So I'll do one of these. So let's do 28. So I have negative 4 times the square root of 252 plus 1. I'm not going to write the 1. Square root of 75 plus 5 square root of 28 minus 3 square root of 3. All right, the 3 is good. Let's break these smaller ones down first. So 75, I think of money, so you have 3 times 25, and your 25 is 5 times 5. So that radical simplified is 5 times the square root of 3. Right, 28 is 4 times 7. 4 is your square there. So you're going to take 1, 2 out times the 5. 5 times 2 is 10. And keep your square root of 7. Right? Minus 3 times square root of 3. Okay, now I have to see what this 252 will do. I am thinking it might have a 3 or a 7 in it because that's what I already have. It doesn't have to have that. And even before that, I'm going to check and see, is it a perfect square so that I don't mess that up again. All right, so we'll check, is it a perfect square? 252. I don't think so. It is not. Okay, so let's break it down. Well, I know there is a 2 in it. So 252 divided by 2 gives me 126. Still not a nice number. All right, the 2 is prime. We'll see what this does. I know there's a 2 in there. So I'm going to divide by 2. And that gives me 63. 63 is good. I have 9 times 7 in it. These 2's are done. This is going to be in the way. Let's see. 9 times 7. 7 is a prime. 9 gives you some 3s. So I'm kind of squishing this here. Right? 2's is a square and 3 is a square. So you've got negative 4 times 2 times 3. And the 7 is left. So 4 times 2 is 8 times 3 is 24. So negative 24 times the square root of 7. Now you can put the like radicals together. So the square root of 7's can go together. Your math is on the outside. Negative 24 plus 10 will be negative 14. Keep the radical. Right? Square root of 3's can go together. Working on the outside, 5 minus 3 is 2. 1 copy of the square root of 3. Now, these are not like radicals, and they are simplified all the way, so there is nothing else we can do to them. And we're good there. All right, I am going to go, and these problems right here are going to work the same. Down through 31 through 32, and then it's to multiplication. So I am going to go to the end and come back. So 33 is where I stopped. I just want to make sure we do some with the eyes. Am I making you dizzy? All right, so let's go to 46. This was a new topic for us. I don't want you to leave it out. It's too important a section, right? And you have to take the I out. I is square root of negative 1. So this is square root of negative 1 times square root of 16. This is an I. Square root of 16 is a perfect square. So this is 4I. Right, next one. Square root of negative 45. Right. First of all, we're going to take out the I, and then we'll break down the 45. We have 5 times 9. 5 is going to stay. 9 is 3 times 3. So you're going to take a 3 outside with your I. we'll just put it in front, and we're going to leave the 5. All right, 48. So we have a negative out there. Don't try to do negative times negative is positive. You can't do that here. All right. This negative underneath tells us there's an I in there. It's going outside. It has nothing to do with that negative outside. And then you're going to simplify your square root of 252. Big number, we're going to have to just play with it. Maybe I should play with it on the side. Let's see if it's a perfect square. It is not. I didn't think it was. All right, 252, I know it has a 2 in it because it ends in an even digit. We did this one recently. So 2 and 126. And then 126, if we do a 2, that will be a 63. And 63 will be 9 times 7. And 9, that 7 is prime. 9 is 3 times 3. So we can take a 3 outside with the I. So this is going to be negative 3I. 7 times 2 is going to give us 14 under the radical. Okay, Miss H did it wrong. 63, I should have had a 2 here. 2 times 63. Bad. I broke the 63 down, but I lost the 2. Okay, so I have a 2 going outside and a 3. 2 times 3 will give me 6 on the outside, and the 7 is left underneath. So we're going to fix this. So it should be a negative 6I. Right, something with their answer key. They keep putting the I after the radical at the end. It's more of a standard practice to put it with this piece in the front, and then it's not going to get under your radical accidentally. If you have it under the radical, it's going to count it wrong. And if I was looking at it and I couldn't tell where it was, it would be wrong. It has to be out from under. I would put it in the front. I wouldn't put it back there. Okay. Sorry about that error. $49. All right, so negative 100, that's going to be 10I. Hopefully that will come to you that fast also. So this is 10I, the I for the negative under the square root, minus, this will be 5, and there's an I underneath. And these you can combine. They both have I's, so 10 minus 5 is 5, and you keep the I. You do the math just like you would if the I was an X. So 5I. All right, adding and subtracting. And again, I would just say treat the I like an X. So to add, we have 9 minus 7I plus 10 plus 21I. And check outside your parentheses. Make sure there's no exponents. There's nothing out in front to distribute. This is a plus Parentheses don't matter. You can take them off. And then put your like pieces together. So your 9 and 10 are going together, and that gives you 19. As a negative 7 and a plus 21 will give us a plus 14, and you keep one copy of the I, just as if it were an x. 7x plus 21x. Right. The subtract ones, watch out, distribute the minus. So this is still question 50. 9 minus 7i minus 10 plus 21i. Right? Take time to distribute that. So minus 10 minus 21i. Nothing in front of this one, so you're allowed to take the parentheses off. And then look for like terms. So let me finish this one and I'll go back. I just saw the thing in the chat. I'm sorry, I didn't see it earlier. So 9 minus 10 is a negative 1. And these, you have to watch your signs. Like signs, add and keep the sign. So negative 28, I. All right, so where did I get, how did I get negative 25? Because I have so many pages here, this is going to be hard. Can you tell me which problem number it was on? 49. Thank you. That makes it easy. So, question 49, how did I get negative 25? You sure that's the question? All right. In the original problem, it has square root of negative 100 and square root of negative 25. So, a perfect square here. The negative gives the I. This would be 10. For 25 perfect square root is 5. The negative gives the I. This comes down. And subtract those. 10 minus 5 is 5. Keep the I. Let me backtrack and see if I can see one where I got a... Okay, very good. I'm sorry I didn't see your question right away. All right, and we did 50. 51, the only difference is you have to simplify these radicals first. You are still adding. You know what? I'm only going to do the subtract. Subtract has more issues than add. So the square root of negative 9 is going to give you 3i. So you have negative 22 plus 3i. That's cleaned up. There's nothing outside. Drop that. Right. Let's clean this one up, and we're going to keep the minus and the parentheses. All right, so we have 21, and this 121, the square root is 11. So this is going to be 11i, so this is minus 11i, but you need to distribute this minus. So this will be minus 21, and this will be plus 11i. Then the parentheses can come off. All right, so our numbers can go together, like signs add and keep the sign, negative 43. Our i's can go together, so 14i, and that is the difference. I didn't do the add one. All right, so next we have a multiplication with the i's. So 4i times 2 plus 5i. You just distribute. So you get 8i plus you get 20i squared. Remember, anytime you get I squared, that is negative 1. So negative 1 times 20 gives us a negative 20 there. And then there's nothing else that we can do. The order should not matter. It should count as right either way. We'll check. So 8i minus 20, and we'll submit it. They were fine with either order. All right, 53 is going to be a FOIL problem. You see two binomials there. All right, so 2 minus 12i and 7 plus 5i. So that says do FOIL. All right, first terms, 2 times 7 is 14. Outside will be 10i. Inside, let's see, I have 12 times 7. So we'll pull a calculator. $84, and it has a negative. Negative 84i. Right, and last, you have a negative 60, but you have I squared. I squared gives you a negative 1 times a negative 60 makes a plus 60. All right, and then you can combine these, so this will give us 74. For your I terms, these are different signs, so we're going to subtract sign of the larger. So 74 minus 74i. All right, let's do 54. This one you just have to not fall for the trick. They want you just to take the 2 to each one, but you're not allowed to do that with the sign in between. What you have to do is write it twice and do FOIL. You could only just take that 2 down if it was multiplication inside. All right, so we multiply. It's FOIL again. So this will be 64 minus 8i, inside minus 8i, and plus I squared, which is going to be negative 1. So 64 and a negative 1 is 63. I terms go together, so it gives us a negative 16. Keep the I. So just to make sure you don't fall for that issue. This one is multiplying conjugates. We'll go ahead and do it, and then we can backtrack. All right, 55. It is two binomials. You don't have to worry so much that they are what we call conjugates. Just don't be surprised when things cancel out. You would see it and do it as a FOIL. So first term's 5 times 5 is 25. Outside is a minus 10i. Inside is a plus 10i. And last is a minus 4i squared. I squared will give us -1 times -4 gives us +4. Right? The 4 combines with the 25 to give 29. Notice your i's cancel. So your answer is just 29. Right. So that way we got the I problems done. Let's go back. I quit at 33. If anybody has requests anytime for specific problems, let me know. I'm happy to do what you want. All right. Basically, things that are inside the radicals multiply and things that are outside the radical multiply. This is going to be a FOIL. So 4 times square root of x plus 5 times square root of y times 4 square root of x minus 5 square root of y. Okay, so it is a FOIL problem. On your first terms, you're going to do 4 times 4 is 16. When you do square root of x times square root of x, it removes the radical and leaves you a plain x. Right, then we're going outside. So numbers outside multiply minus 20. Right, this time you're not doing the same radical. You're doing square root of x times square root of y. They're going to just stay under the radical together. Inside, this will be plus 20 on the outside. And this is going to be xy or yx. I would go ahead and put them in alphabetical order so I could recognize, like pieces. Right, and then I'm down to my last terms. So 5 times -5 is a -25. Square root of y times square root of y takes the radical off. All right, so we're done multiplying. You're looking at addition, and these two are going to cancel. So these must have been conjugates. Same pieces, opposite sign in the middle. They were conjugates. So you don't have to recognize them, just go through your steps. But they cause canceling to happen, which is nice. All right, so I'm going to skip the next one. Just remember, things outside the radical multiply, things underneath the radical multiply. And same square root times itself removes the radical. 35, write it twice and do FOIL. I'm going to skip it. 36, this is also a FOIL, and these are going to be conjugates. So things outside multiply, things underneath multiply. There's no reason to do that one. It's like what we did. Okay. This one is a distribution problem. I don't really see anything weird in it. So square root of 2 times -4 plus 5 square root of 2. It multiplies by each one. The -4 just has to stay on the outside. It can't do anything with that underneath. And this will be 5 times, this is a 1 outside. So the 5 and the 1 multiply. But when you do square root of 2 times square root of 2, it takes the radical off and gives you a plain 2. So this gives us a 10. -4 square root of 2 plus 10. So they cannot go together. All right, this would be similar, so we'll skip it. All right, good. Let's do rationalizing a denominator. So this is a different kind of skill, not a hard thing. You're not allowed to leave radical in the denominator. Then you can't leave a fraction under a radical. So was that the last question, Bella? Let me do this one and I'll go back, okay? 33, okay. Let me do this one and I'll go back to 33. All right, so go ahead and split it apart. Put the radical with the numerator, radical with the denominator, and 25 is a perfect square, so 5 over the square root of x. We've cleaned up everything we can, but you are not allowed to leave a radical in the denominator. I'm just going to recopy so I have this all together. So I have to get rid of this radical in the denominator. If I multiply by a square root of x, that will give me a perfect square there, and I'll have no more radical. Whatever you do to the denominator, you have to do the same thing to the numerator. And so these will give us just x, and this will be 5 times the square root of x. All right, let's check that. Okay, so I had a question on 33, so let's go back. And the question was the root of xy. We'll just do it again so I have it all here. I have too many pages. It won't let me get back through those. So 4 square root of x plus 5 square root of y times 4 square root of x minus 5 square root of y. Okay, and we're doing a FOIL. Right, so we're going to do first terms, which are these two. Right, pieces outside multiply, so 4 times 4 is 16. Square root of x times square root of x will take the radical off. And so this will just give us x. So that's our first one. Outside is here. And so pieces outside multiply, so that gives us minus 20. And square root, x and y are going to go underneath the radical. All right, and then inside, your 5 and your 4 are plus 20, and you have xy on the inside. And then last, minus 25, square root of y times square root of y takes the radical off. All right. If they did not cancel out at the end, what would they be when added together? You would do all the math on the outside. So you're asking if this was like a 4 and this was a 20. So they're not going to cancel. You would keep only one copy of the radical. So let's sidetrack and do something different. If we have 4 times the square root of xy plus 20 times the square root of xy, they're not going to cancel out. Your math is on the outside. And you keep one copy of the radical. So this part in here is not changing. They have to be like radicals to put them together. Did I answer your question? Okay, very good. All right, I think that we are out of time. But we did one rationalizing the denominator, so I think that we are pretty good. That was near the end of the stuff. All right? So you guys work hard for your test. Do this practice thing. The problems will be similar to what I did. All right? And I will check on that link that I sent out to you guys about the ASC, that review, because some student told me that the link is wrong, that it's just sending you for the live review, so you're sitting in a Collaborate room all by yourself. So I will check that, and please tell me anytime if something like that happens. All right, you guys have an awesome day, and I am going to stop the video. If you have any questions, you can hang out.